This is Mr. Navi from Roger Bacon High School, and today's lesson is on equations. I have 5 problems listed here. What I'd like you to do is to take about 2 minutes to see if you can figure out which values, if placed in the boxes here, would make the equation true. So I'd like you to actually stop the video, take 2 or 3 minutes, solve each of the equations, and then once you've finished, come back and we'll go over the answers. So this time, pause the video. Okay, we should be back. Now, let's talk about what values should be placed in the box to make each of the equations true. In the first box, you want to ask what number plus 10 equals 23. Well, if I add 13 to 10, that gives me 23. In the second box, what number divided by 2 would give you 7? Well, I know that 7 is half of 14. For the third question, 3 times what number minus 7 is 29? If you're not sure on this one, because it is a multi-step problem, you might try estimating. I know that 30 is close to 29, so 3 times 10 might be my first guess. And 30 minus 7 is 23. Well, that's too low, so we'll readjust our estimation, and I think it's 12. 3 times 12 is 36. 36 minus 7 is 29. For problem 4, what number added to 5 and then divided by 10 gives us 2? Now this is a multi-step problem, and again, we want to know what do I divide by 10 to get 2? Well, 20 divided by 10 is 2. So in order to get 20 in the numerator, the box would have to be 15. Because 15 plus 5 is 20, divided by 10 is 2. And the last question, what number minus 17 is negative 3? Since the answer is a negative 3, I know that this number in the box has to be less than 17. Has to be a smaller value than 17. And I actually want the number that is 3 smaller than 17. So if I do 14 minus 17, I do get negative 3. Up to this point, we've been dealing mainly with expressions. And an expression is an algebraic way of writing a value. In the problem that you see here, 2x plus 5 equals 13, this is actually an equation. And what makes it an equation is that it has an equal sign. If we ignored the equal sign in the 13 and only had 2x plus 5, this is what you've seen before, is known as an expression. And you evaluate expressions by placing values in for the variable x. If you have an equation, you solve an equation. In other words, you want to know what value will I place for x that makes the equation true. So let's try this. And in order to do this, I'm going to create a table. A table is a great math strategy to help not only organize your work, but to see the logic and how the values are changing. So I've got 2x plus 5 equals 13. And I want to see which of these numbers, 2, 3, 4, 5, and 6, when replaced for x, will give me a solution of 13. So let's try this. 2 times 2 plus 5 equals 13. I replaced x with 2. 2 times 3 plus 5 equals 13. I replaced x with 3. 2 times 4 plus 5 equals 13. I replaced the x with 4. 2 times 5 plus 5 equals 13. I replaced the x with 5. And 2 times 6 plus 5 equals 13. I replaced the x here with 6. Now I have to decide which of these statements actually is true. 2 times 2 is 4, plus 5 is 9. I know that's not equal to 13. This statement was false. 2 times 3 is 6, plus 5, that's actually 11, not 13, so that statement was false. 2 times 4 is 8, plus 5 is 13, and that's actually what I wanted. That statement is true. 2 times 5 is 10, plus 5 is not equal to 13, that's 15, that statement is false. And then 2 times 6 plus 5 is not 13, that actually would be 17, that statement is false. So actually, the only answer that works is when x is equivalent to 4. So x equals 4 is the value that makes this equation true. Another strategy for solving an equation is to first simplify. So here we have an equation, 7 minus the quantity of 4 squared minus 10 plus n equals 10. And before we solve for n, we want to simplify by using the order of operations, which you're familiar with as PEMDAS. Parentheses, exponents, multiplication or division, whichever comes first, addition or subtraction, whichever comes first. So we'll come up here to the parentheses, and within the parentheses we will evaluate the 4 squared first. So I've got 16, and I'll bring everything else on down. And I'll complete the parentheses. 16 minus 10 is 6. Write everything else out. We'll simplify again. Now notice I do have subtraction and addition side by side. And with order of operations, if those two operations come one after the next, you always read, just like an English sentence, left to right. So we actually need to do the 7 minus 6 first to get 1. And at this point, the problem looks a lot like the problem we saw at the beginning of the video. And 1 plus what number is equal to 10? Well, I know that I have to add 9 to 1 to get 10. So in fact, the solution for the variable is 9. N has to equal 9 in order to make the equation true. Finally, there are equations that have no solution. And here's an example. I first want to use the distributive property and distribute the 4 to both n and 3. We did that in the last lesson. 4n is 4 times n. 4 times 3 is 12. And here I have 4n plus 13. Now notice I have 4n plus 12 on one side and 4n plus 13 on the other. Now I'm not sure how to figure out what values will make this equation true, so I'm just going to pick a few. So what if n were 0? Let's just pick a few values that we can check. 4 times 0 is 0, plus 12 is 12. And 4 times 0 plus 13 is 13. And 12 is not equal to 13, so 0 doesn't work. Let's try 1. 4 times 1 is 4, plus 12, that would be 16 on the left side of the equation. 4 times 1 is 4, plus 13, that would be 17 on the right side of the equation. And 16 is definitely not equal to 17, so 1 doesn't work. And let's try one more. What if n were 2? 4 times 2 is 8, plus 12, that would be 20. And 4 times 2 is 8, plus 13, that would be 21. And you know that 20 and 21 are not equal. But there's actually a pattern here. It seems that no matter what value I replace n with, the right side of the equation always seems to be 1 more than the left side. And that's going to be true for any value you could ever possibly think of for n. So since the sides of the equation are never going to be the same, because the right is always 1 more than the left, we say that this problem has no solution. For practice, you should check a few problems at the end of Chapter 1, Section 5, Simplifying Equations, Evaluating and Solving Equations, at the end of that chapter in preparation for tomorrow's class. And this is the end of your video.